Okay, I think we're good to go. Let's do this. Yes. Hello everyone and welcome back to my YouTube channel. I'm Yvonne and I'm going to show you the app that I built. Okay, so what is this app? This is CodeRes.ai and it's an app that would help you generate code from figures, from published figures in scientific papers, right? So I'm just going to show you what it does. You can try it now, but first the landing page. So it's powered by Gemini. Slay Google. You upload your figure, you get the code, and you can get it in multiple languages and get like a little bit of explanation. So that's the landing page. I'm just going to show how it works. So I'll try it now. I'm going to upload a figure from a particular paper I was reading. Yeah, a lot of like really complex data over here, but we are going to try this out. Get code. So you can see here I can get my code in whatever language that I want. I'm going to generate code and let's see what Gemini is going to give me in Python. Alright, so we have here some code for like the different plots in this figure. So the heat map, and it would explain a little bit more about what the plot is talking about, which should give me some context to the paper that I'm reading. Yeah, I definitely have to tweak this, but this is what I have so far. Yay. So yeah, the reason for building this was because I was getting really frustrated in my literature review process. Like I tend to go into a really deep rabbit hole and trying to parse through all the scientific jargon of all the papers and all the new words, all the new terminology, like walking through mud. Because my brain was like, she would not allow me to progress until she understands a particular sentence and everything that it's conveying. So what I needed was like a structured introduction to terminology and use cases and how the different data related, how like certain parts of the paper related to the figures, how the methods that they would explain in the paper were reflected in the figures as well, like all of that. And a lot of you know, reading like scientific papers, especially in the field that you're not necessarily well versed in, even though you might be a scientist in one field, is kind of hard because it's like you're the new kid on the block and you're joining a group of finance bros talking about their finance bro stuff. You know how they talk, like it's like, I don't know, I think I saw this video on Instagram. Was it finance bro? It was consultant. Oh my gosh, bro jargon, Instagram meme.
Vicious, idiosyncratic question you're asking there. Before we get into the Sauvignon Blanc of the question, we must first ask ourselves, what is the Shawshank Redemption in the orthopedic doppelganger that was compiled?
Yeah, kind of like that. I think this holds true for like any book that you pick up that is in a different field that you're in, you know. And the scientists have to focus on communicating with each other, right? Rather than making their papers beginner friendly. So it's up to you, the new person on the block, the new person in the field. Or even if you have some preliminary knowledge of like the concepts, kind of relating what you're reading in the paper to what you know also takes considerable effort, right? So that was the reason for building this app. And it's up to you as a newbie to learn the jargon. So I'm just gonna show you exactly what I mean with the paper that I was reading and the paper that I used in my demo. Okay, so I'm looking at this paper titled the single cell pathology landscape of breast cancer. And essentially what it's talking about is the use of imaging mass spectrometry to simultaneously quantify 35 biomarkers, blah, 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 from tissue samples, tumor tissue samples, right? And I'm like interested in this. I want to see their methods. I want to see what they did. I want to understand what's going on. So I'm reading this, and usually I start from the methods because that would give me some semblance of familiarity with regards to like stuff that I already know. So I'm looking at the data, data reporting, clinical data. I understand everything that's going on here. The panel, an antibody panel, was designed to target epitopes specific for breast cancer, as well as markers for cell cycle and phosphorylation-based signaling to distinguish epithelial, endothelial, mesenchymal, and immune cell types. I understand all of that. Oh my gosh, like I've come so far. Yeah. And then we look at the preparation and staining. Tissue samples were formalin fixed, paraffin embedded FFPE samples. And the antibody panel, oh my gosh, I understand. Described in the extended data, figure 1 was used to stain the tissue sections. Tissue sections were dewaxed in xylene overnight and rehydrated in a graded series of alcohol, ethanol, deionized water, blah, 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 blah. See, I look at this, and my training so far as a research assistant has really opened up my mind, because 2 years ago, or maybe a year ago actually, I would not have understood a lot of, maybe I would have understood it to a degree. I would have like some semblance of understanding, but it would not be as concrete as it is now, right? So where I'm at right now in trying to better myself and my scientific skills is with the processing of the data and trying to derive insights from the data. So let's go to their data processing. Okay, let's see what they're saying. Well, we can start here. Data transformation and normalization. Or we can start here actually, data processing. The data was converted to TIFF format and segmented into single cells in the flexible analysis pipeline available here. In brief, individual cells and the use of tumors was segmented using a combination of elastic. I know what elastic is. And cell profiler. I know what cell profiler is. Yay. Anyway, where are we? Yeah. Elastic was used to generate a probability map, all that. So I kind of get the premise of this entire paragraph right here. So now let's go to the data transformation and normalization. Now this is where it gets interesting, okay? The presented data were not transformed and all analyses were based on raw IMC measurements. Single cell marker expressions are summarized by mean pixel values for each channel. Okay, I get that. The single cell data was censored at the 99th percentile to remove outliers. Okay, I know what 99th percentile is. I know what outliers are. And they were censored. That's great. Perfect. We understand the reason for that. And z-score cluster means were visualized in heat maps. For TSN, okay, so we already have like 2 words. I'm like, okay, what's that? For TSNE and phenograph, the data were normalized to 99th percentile as suggested for these algorithms. Okay, now this is where I get stuck. Because I'm like, okay, how does this part relate to the figures? You know what I mean? I want to see the correlation. I want to see like the relationship between the text here and where it applies in the paper itself, you know? And that, my friends, if you don't understand to a concrete level, or if you have a fuzzy understanding, it's gonna be really hard. Okay, so I think my first thing, I'm just gonna Google what TSNE is. Okay, so statistical method for visualizing high dimensional data by giving each data point a location in 2 or 3 dimensional that makes sense. I know what this is. So you see, like, wow. Anyway, so back to the paper. What my brain would do is when we get to a term that we don't know, she would be like, no, we're not progressing past this point. We're not going to process anything or any sentence past this point. You have to figure out what this means, right? And just Googling it was so easy. And now I understand, right? But here's the catch, right? I understand what it means, but do I understand how it's used in relation to what it means? That is a question. So that's a second layer question, right? And I think one issue that I have is if you're reading a lot of these papers and you're encountering new concepts and such like that, you can get into this problem of zigzagging between new concepts in your search for understanding and Googling or deep diving every concept, and then you end up just not getting very far in the paper or in understanding the paper. So yeah, that is the reason why I created this app, CodeRes.ai. But yeah, it's a far cry from what I actually wanted to do, and I will show you how. But I saw the Google Gemini API competition and I was like, you know what? I could combine this need. There is a need, as my professor would say. I could combine this need for clarity in my literature review process with the competition and down 2 birds with 1 stone. Okay, so that's what we did. I'm going to walk through my Notion. Google Gemini API competition. Yay! So I wrote down everything, the deadline. This was the deadline. The resources, learn Gemini, enter the competition, blah, 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 blah. And then YouTube videos that I watched. How to use the Gemini. How to join the competition, how to use the API, the GitHub of Node.js Gemini API examples, which is really helpful, and a couple of tutorials on how to build a full stack SaaS platform, which were really helpful. Yeah. So I will walk through my design history file, and maybe we'd go through the video, my video script for my video. Oh my gosh, it's been 16 minutes already. Anyway, so this was the rough idea, like the initial idea. It was supposed to be like a data replication pipeline for scientific literature. So it was an AI-powered app that's able to interpret the code scripts from the paper. So most papers give you links to your code. Like, you remember the GitHub that was in the paper, right? So the initial idea was to just take that code and generate a descriptive pipeline that would help other researchers understand the pipeline and replicate the data, and it will help with like reproducibility and the scientific literature process and all that. So yeah, and it will also help individuals who have learning disabilities parse through really complex scientific papers with complex computational pipelines. Yeah, and bridge the gap between coding tutorials and the real world use cases in scientific papers. Okay, so my model as of 14 July, this was when I created this design history file. My model was first to take the paper, take the figures, and generate the code when no code is provided. And the second model was to take the paper and the code when the code is provided, and generate a pipeline and relate the figures in the paper to the code and to the pipeline. So that was how I simplified it. I broke it down into 2, simplified it, and worked on this first. And this is the only part I was able to ship. Actually, I was only able to ship this part, just the figures and the code. Forget the paper. But yeah. So this was the problem that we're solving. Just a brief rundown. I'm just gonna go through this really fast. And this is me just trying to apply what I learned as a biomedical engineer, problem definition and need statement and background research and all that during my senior design project. But yeah, so let's look at the design timeline. Oh my gosh, so this is what I planned. Oh my gosh. Did it go according to plan? That's another question for another time. But yeah, at the time I was learning Next.js. I didn't know any Next.js, and prior to that I was learning the React. So I was like, you know what, let's finish our Next.js tutorial, and then we'll start working on the functionality the following week and do the UI design, the edge cases and UI functionality video, and then create the submission video, polish code in the video, and then submit. Yay! It's probably not gonna go according to plan, but that's okay. Let me write that down. Yeah. So execution, let's see what actually happened. We actually finished half of the tutorial and we stopped at chapter 9. Because I was like, okay, you know what, let's stop this and let's just start building, right? So we worked on the functionality, we did more UI, UI design and so okay, yeah, let me elaborate on what I mean by functionality. So this was where I tested the Node.js examples from the GitHub that was provided in the Google Gemini API intro videos. Just tested them on my concept in the command line, really simple. And then here's when I actually started building the app with the UI and integrating with functionality and all of that. And then continued and made the video, filmed the video, did more coding, and I was done with my first year MVP by I think the 3rd of August. This might be a lie, but that's okay. And I polished the code, but I didn't push it until the last minute. Like I pushed it on 12th of August to rest out. And I got a lot of errors. But I was able to submit it in time. So yeah. And I actually began with editing the video the day before. Guys, plan well, so don't procrastinate, okay? And plan well so you don't have to end up like me. But I was able to submit it, so that's good. Although the audio wasn't as great in the video. But yeah. Okay, so my design tools. Look at my tech stack. Next.js, Tailwind, CSS, Shot, CNUI, Daisy UI, of course the Google Gemini API, and I did all of that in TypeScript. Also, I didn't do any TypeScript. My first and only exposure to TypeScript was through the Next.js tutorial. So that's for another day. We have to polish our understanding of TypeScript, but we were able to use it to make an app, so slay. Next up, we have the logo design, of course, Canva. Here we go. And Preview and GIMP. And the packages I use. So I had to what I did was type every single package that I used in the order that I installed it. Because I was like, what if it doesn't work the next time I install them in another order? You know what I mean? So yeah, these are all the packages that I use. Let's just say, are they called packages? I think so. Yeah, no package manager, right? Yeah, packages. And this was my initial design after watching the Google Gemini API videos. And as you can see, nothing went according to plan. Also, at the time, I planned using the Gemini Pro models, but I think now they have the Gemini 1.5 Flash model. So yeah, and then I made a rough draft of the UI. So this is what we had initially. My landing page right here. This is what it was gonna look like. And then we had the try it page, and this is where I was going to do the second model. So the second layer MVP. But this is for the first layer MVP. And then the main try it page, where we had the paper here. It was supposed to be the paper, the PDF. The figure went here. And then the code boxes would be here. Slay. So yeah, that was basically it. And I wanted to add a section where you could chat with Gemini about the figure. But that will be later. I will be pushing new updates to the app, but that will be for later. Okay, let's go back to my design history file. So my app features landing page, try it page, where you upload a PDF of the paper, which later on changed to a PNG picture of a figure. and the tried page where you post a link to the paper and it just automatically gets the code if the paper has a GitHub, and then that's the pipeline for you to visualize. And then we had the main functionality page. I'll have the model, paper, figures, and then you'll get the code and the second model as well. So yeah, look at my tasks, slay. So productive. I polished my design history file on the day of the 14th of July. And of course, my rough draft of the design in GoodNotes. And then I did my basic landing page also on the 14th of July. And my logo design. Okay, so this was the logo design I actually came up with. This is my landing page. I was like, I need a baker. I'm gonna put code in it or put like some tags in it. And I was able to design a pretty logo. Look at her, she's slaying. Anyway, so yeah, designed the logo in Canva, and then I did the upload PDF page. Initially it was a PDF, but I changed it to a PNG. And I was trying out different Tailwind UI components. Yeah, this is what it looked like. So I planned this. This was the first model. So I planned this for the week of the 14th of July. But I finished on the 28th. Yay. Yeah. So I modified it to accept and display images in addition to PDFs, but as of now it's only images. So yeah. So I then added the Gemini API. Successfully added the Gemini API after debugging and dying. Of course, that part was the hardest because I was like, how do I translate it from Node.js to Next.js? Okay. How do I transfer it from Node.js to Next.js to TypeScript? Translate. And using all of the React components and all that, like that was the hardest part because, like, as I said, preliminary information. I'm like a super beginner. I'm not a developer by training, so this was all trial and error. But I did it, yay. So yeah. Polishing the main functionality page and then work on the landing page. After I did that part, I did the code part with React. I polished the code part with like React Markdown. Added buttons for uploading new file and generating the code. Added icons and labels for the file and code views, and added a copy code button and a drop down menu to select multiple languages. Great. And then on the 29th of July, 1st of August, and 6th of August, I polished the landing page. Yeah. With my components from ShiftFast. Slay. Also, don't tell me, I just asked ChatGPT. Oh my gosh, I'm betraying Gemini. I'll cut this part out. But yeah. So I polished my landing page and added components from ShiftFast. Polished my landing page, added components from ShiftFast, and added my Daisy UI stuff in edit in the footer and privacy policy. Okay, great. And then I added the features bar, the grade component from ShiftFast, and the FAQs. Did I add the FAQs? I don't think I ended up adding that. Let me check. Yeah, I didn't add the FAQ part. I was like, later, but I never ended up adding it. So the second MVP that I was gonna ship would be the pipeline. Probably be doing some stuff with Mermaid Live or Planet UML. So the second, yeah, that's what I plan on doing. In the second part, I'll probably ask the user to paste the GitHub or those are Nodo links. I know there's a platform that scientists use to share code and data. And then you would obtain the detailed computational pipelines from the relationship between the various, this is supposed to be V, various coding scripts he's integrating the paper and blah blah blah. Yeah. And this is the paper that I use, single cell pathology landscape of breast cancer. The paper from which I got the figure to use for the demo. Really good paper. Check it out. Yeah, and this is my app submission. CodeRes.ai is, oh my goodness. I can't believe I made that mistake. Anyway, CodeRes.ai is I'm pretty sure they put this, because I just typed this in on a whim. I was like, ugh. So late. But yeah, I uploaded the video, the web app URL. This is the actual URL. This one, I probably have to buy the domain. I will be buying the domain or getting the domain. Yeah. So yeah, that's me. Slay. And that was the whole premise of the paper. What did I say of the paper? Of my building timeline as a beginner. Haha. Okay, so we're gonna go to the video script, because the video was actually supposed to be longer than it actually ended up being. It's supposed to be long. Yeah, and this was the timeline that I used to script, film, edit, done. So this was the script idea. So what I wanted was we would have all of our various interests in mission control, which is the brain. We have the scientists who will be managing the brain and managing R&D, which is research and development. We have the software developer, that's me also, and this is also me. And then we have the engineer, also me. Problem solving, also me. Creativity and innovation, also me. Critical thinking, also me. Sleep, also me. But yeah, now these will be the different parts of my brain that will be starring in the film, but not all of them showed up. Like these four did not show up. It was only these three. Oh my gosh. Yeah. So initially, so this was like the whole script of the thingy. It was really long. I'm not gonna go through the whole video, but you can watch the shortened, abbreviated version on my channel with really terrible audio. Sorry about that. Okay, but yeah, this was the whole premise. I'm going to be updating my app, pushing out new features. Hopefully Gemini still stays free, so if there are any more API calls, I don't get charged. I have to go check that though, because my API key, they're probably gonna be charging me. But yeah, go vote for my app. Go vote for my app, please. I want to win the People's Choice Award, so go vote for the app. She's a beauty, she's gorgeous, she's slay. You can contact me here or with my content creation email. But yeah, thanks for watching. See you. Oh yeah, wait. This was supposed to be a recap video. This is supposed to be a recap video of my whole building process, so anybody who is new to the whole indie developer game can get a sense of what one beginner indie developer is doing in her free time. And essentially, the app that I built was supposed to scratch my itch, and it's going to scratch my itch, of course. It's going to help me understand all these papers with the optimum clarity. That is what we need. We need concrete understanding of every single part of every paper that we read, so that our understanding is not fuzzy. We don't want any fuzzy, cloud-like, hazy, I know what this is, but I'm not sure kind of understanding. No. Right? And the second thing is, what is the second thing? Once we have this concrete understanding, we'll be able to leverage it in other spheres of our scientific knowledge and come up with new discoveries and all of that. Because there's a big difference between hearing something, knowing something, understanding that thing in theory, and understanding how to use it. Like, all these stages have different levels of knowledge acquisition related to them, and we need to nail it on the head. All of them. We need to gather all the knowledge into our brain and take action on it. That's the number 2 part. Not only gathering the knowledge, but taking action on it in our work. So yeah, vote for my app. I will link the voting thingy in the description. The voting link in the description. Please vote for me, I beg you. Okay, bye. Subscribe, like the video, comment, do all of that. Hopefully this helps somebody. See ya.